Welcome to my 88K model railroad video, and this is the continuation of our field fix for the HO transfer table. This is the Cornerstone 933-3131 table. It was the initial release, I think back in 2000 or early 2000. Now this table had a lot of issues with it, and that's part of the basis of this video. In part one, we went over the premise of the video, why we were targeting this transfer table, and then some of the issues that the table had and kind of what we thought we needed to address. So the table's working fine now, the issues are clear. And what we're going to do is we're going to watch it run real quick. Then we're going to talk about what it took to get the problems resolved and then what's next. So let's swing over to the bench. Okay, so here we are at the bench, and I was able to locate a kit. And I put some of the basic pieces together, the bogies, here to show you exactly what goes wrong. This basic frame, or the bridge, is actually tweaked, and if you see here, you can see that the corners are twisted, and that becomes the beginning of the trouble because the unit isn't square. As you start to build and bring the bogies and all the pieces together, it's not going to sit straight and flat. And you need that in order for the gears to mesh with the, or actually I should say the pinion. So it works with a pinion and a rack. And because this is tweaked, then the gears are not going to set in the pinion, and you're going to have, or the pinions are not going to set in the rack, and you're going to have trouble. So you almost need to ensure that everything's squared by putting a, these are called 1, 2, 3 blocks, 1 inches by 2 inches by 3. And if you notice when I put it down, you can see that this back piece starts to level out, and then you lose that play. So now this is squared. So as you build this, you have to put in the, or as you put the glue or the cement in the joints, then you put something heavy to force it squared, and then hopefully when it dries, it's squared to the base or the bottom of the bogies. So I was able to, or I should say in a forum, a guy mentioned that he put lead weights inside of his unit and got it to work a lot better. But the problem that I had is once you put the weights in here and you put the cover and glue it, you cannot access those metal pieces anymore. So that was the problem that I had. And what I ended up doing is putting in brass pieces. So I made these cutouts of brass, and I used double-sided tape. It's a high quality tape. It's called Tessa tape. And I mounted the brass pieces on, so that gave me a lot of weight that then ended up making this square. So the key to the bridge working is making sure that everything's squared, and when it's squared, then that means the gears here, these pinion gears, are sitting in the rack. And if you remember, I took my pit and I upgraded the rails from the code 55 to code 83. That lifted this up just a little bit so the teeth would mesh in the gears, or not the gears, but into the rack a lot easier. So that's why the bridge has a real smooth movement in the rack, or the pinions movement is smooth inside the rack. The next thing that I did was I put a torsion bar here to help try to square things up. And this is like a 0.77 rod, inch rod, and I put 2 millimeter threads on it with these nuts, and I ended up putting the blocks here to hold it flat, and then I tightened up the nut. So I think that helps out a lot and acts as a torsion bar. So this really runs smooth, and we'll look at it in just a moment. So the next thing, as I got everything flat, what I did was I placed a magnet here on the end to start working on the indexing. So this unit is pretty much squared. It has the Digitrax decoder in. I stated that I was going to swap that out, but I'll just do that later on whenever I go into the not Rocrail, but Railcom. I want to try to do some things with Railcom with this. So the way this works is the bridge has 2 inputs, one for the DC motor and then pickups for the rails on the bridge. And that's these pickups here. You can see there's 4 of them. 2 in the center goes to the cab, and then the 2 on the outside goes to the rails. And in order to make this DCC, I just moved the pickups from the motor and moved it over to the decoder. And here you can see I've got a little PCB or a prototype board, and that allows me to solder all the wiring, and it makes it a lot easier. And then I double stick the tape, and then here you can see the wiring that I made, reroute the wiring from the pickups to the decoder. And then here's the magnet wire that runs up to the beacon light. And that light is off of the forward headlight, and I just changed it to a beacon light, and then it's got the yellow LED. So that pretty much, oh, and then also there's a the LED for the cab, and you can see it's just a regular LED with the legs bent, and you can put the house back on or the cab back on, and that pretty much sets up. I think F3 will turn on the cab light. So this is the basic fundamentals of getting this squared. And oh, one more thing, the pinion gear here on the end, what you've got to do is to make sure that the teeth are aligned on both sides. So you would put one of the teeth down at, let's say, 6 o'clock, and then on the other side, make sure that tooth is straight down at 6 o'clock, and this is balanced. That way you can stop it from skewing, because if it's off a little bit, let's say one tooth is back and one is front, or a little bit in front, then that's going to cause it to be off camber, and it's going to roll forward, and the further you get into the rack, the more it's going to twist. So that's something that you need to make sure that you do. Also, the wheels, fortunately, I did not glue the axles together, and I was able to pull this apart and drop the wheels. Now, the instructions have you to have the flange set 1, 2, 3 with the flange to the right, and then the last 2 flange, you set it to the left. But what I did was I moved everything to one side so the flanges are all equal. That way the bridge can move and settle to where it wants. If you put them in the way the book or the instruction says, then it's going to lock it in, and it will cause it to bind if it's not level, and that table isn't level. So this are the little tweaks that you have to do to get this going right. So with that, let's pull in the pit and let's run it a little bit. So let me do that. Okay, so we've got the bridge in the pit, and let's run the bridge real quick. And here you can see that it is running smooth, and that the motor's not hindered by the brass weights that we have. So here, let's run it back. Then you can see the cab light is on. Cut the cab light off. And with the decoder, now you have full control. There's a couple of other not relays, but the not LEDs, the resistors I've got in there, and there's two more positions that you could add on to control something, if it's another light or whatever. So we've got that set. Now the next thing to look at is the indexing. So with the indexing, I have a magnet here, and I've got the Hall's effects sensors here, and you can see them along the edges, and the sensor is actually there. So as the magnet passes, you can see that it will light up. And let's run it through real quick. Okay, there. And now the LED is reflecting the magnetic field, or not reflecting, but is indicating that it's in the field. Now we're going to use Rocrail to control this positioning of the table, and that's happening via the module that I put in. And this is the same basic setup that we did in the other video. This is an ESP32. It has the here, let me shut it off, and then I bring it over so you can see. Let's let me shut it off and move it over. Okay, here we go. So we have the module here. You can see that the LED, or blue LED, is flashing because it's connected to the Wi-Fi, and I've got it actually connected to Rocrail. This is the ESP32. It has the WIO firmware written into it, and that's just like the previous videos that I had for the WIO. I've got a Darlington transistor array set here, but you don't really need it. There's a guy, BBCSD, that pointed out you can do a pull up and pull down resistor that will eliminate the need for the Darlington transistor array. If you set the sensor up for a pull up sensor, or I'm sorry, a pull-up resistor. If you add that to the signal lead, then everything will be okay. And you just saw it light, and as the magnetic field went past the sensor, that it shined red, and then that would send back the indication to the module here to then show that the sensor is high. And from there, Rocrail will know that there's a that this sensor has been triggered. So that's the next thing that we're going to get into, is configuring this transfer table to operate in Rocrail, or actually to have Rocrail operate the transfer table. So hopefully this will help you guys out, and you'll be able to fix your transfer table if you have one, or if you can get a hold of this kit. It's actually a viable kit now that you could probably use in most cases by putting in these little fixes here. So with that, I'm going to close up. The next video in part 3 is going to be the Rocrail aspect of it and getting everything working there. So as usual, like, subscribe, and we'll talk to you guys later.